All right, Hangout on Air is now live. Great. Okay, this is the tracing working group meeting. Let's start off with everybody introducing themselves real quick. I'm Michael Rogers. Go Bradley.
I'm Bradley Meck. I just work at NodeSource, that's it.
Fadi.
I'm Fadi. I'm working on the tracing CLs and V8s. I have also Nat Duka and Ali here. Hey guys.
I'm Nat. I am Chrome's performance sort of conductor or something, but Trace event is kind of a overgrown 20% project of mine, so that's why I'm involved here.
Yep, and I'm Ali. I'm working on Node, and I do this.
Hey, Ollie, you're going to have to speak up a little bit.
Or get closer to the mic.
Yeah. So my name is Ali. I'm working on Node and io.js at Google.
Thanks for being here, you guys. It's going to be super helpful.
And that's Trevor Norris.
I'm a maintainer.
Steven.
I'm Steven. I write node instrumentation at AppNode.
Cool. Okay. All right. So to get us started off in the first part of the agenda, we just have sort of like a what is trace event. So if we could get sort of a breakdown of how it was created and why and what the primary use cases are. I'll let the team at Google take that one.
Okay, so trace event is a thing we developed for client-side performance analysis of Chrome. Chrome's super multi-threaded, and there's a lot of structural performance information that matters to us. We haven't historically been very interested in sampling, sort of, getting in a stack trace every couple milliseconds. We instead found that we got much better data from structural information, like the message loop is running this task at this time, and so on and so forth. So trace event is just it's two things. One is it's a data format, this JSON file format thing. But on the C++ side, it's a way of sprinkling probes throughout the Chrome code base, many different libraries, where we can dump in probes and then get them out to sort of a central buffer, and then into this file so that we can then post-process it after the fact. And we've come up with a set of API calls there that we think work pretty well, the various types of events, counters, async events, sync events, flow events. We're always adding new ones. But
with regard to that, so I see, in source tracing, tracing-event.h, that is a pretty massive API you have there. But with regards to, there's a V8 patch in the document, in the agenda. In V8 include V8 tracing.h. Like, I'm failing to see how that tiny class API reflects the massive API in tracing.
That's the key trick. Because the problem is, in big code bases, you have like 5 different libraries that you have to pull together, right? And so you're like, I want to keep this API small, right?
Mm-hmm.
And then you go, oh my God, look at all these goddamn trace event macros, right?
Yeah.
And it's horrifying. The key thing is traceEvent.h bottoms out in, I think, three actual C++ calls, and all those, 3 or 4 C++ calls with very specific purposes, and the macros just sort of turn into those 3 things. So if you look in that traceEvent.h, you'll see that there are these internal API underscore and then some other crap.
Yeah.
The design here is that you copy that big monster file into your whatever library you're trying to add trace event to, and then you only have to expose the 3 internal APIs and route those back out to the outside world. So,
I see. So anybody that would want to use this v8 tracing.h, they would still have to bring in the tracing event.h?
So you copy and trace event.h, and then you hack that file to point the internal API calls to point at point back out to, in our case, to Chromium's base library. In your case, to some base level library, right?
Okay.
Basically, all you need to implement is just these 4 methods, and everything magically works. And either, like in Chrome, what we do is we take these 4 methods and just we make a call to their corresponding Chrome 4 methods. So we just make a call from each. Or you can just dump to a log file. You can do whatever you want in there. But you have 4 concrete points where you only need to implement there.
And the whole theory here is that that low-level abstraction is not very fun to talk to as a programmer. But from an embedding point of view, the low-level abstraction is, hey, tracing system, I have an event for you, and here's the parameters of the event. Hey, tracing system, please give me a pointer to tell me when tracing's on that I can pull. And I think there's one other.
There is update duration and then add trace.
Yeah, so they're basically like, it's like a couple little details, but basically it's these 2 things, right? It's like, hey, tracing system, here's an event, please put it in your buffer.
Yeah, and it looks like you can create groups of tracing, and then can you, like, let's see. So update tracing duration happens on a specific event tracer handle, but then you can...
Yeah, that's a corner case. That's a very particular quirk.
Okay.
Yeah, I would kind of blur your eyes and not look at that, like pretend that it doesn't exist.
Okay.
That's because when you look at a single thread trace, the vast majority of your traces are I began doing something, and then later you say I finished doing something.
Yeah.
And you can have the number of events in your trace by taking all the begins and ends and combining them. And so the update thing is about we have this hack that allows you to say begin an event, and then you hang on to a handle for it, and then later you can say, hey, this is how long the event took. It's just a corner case that's just a very important performance optimization, I guess.
Now, if I may, I'm just super curious. The handle property in the class is a uint64, so does each trace event just become a UID?
No, that's the position in the trace buffer that gets returned.
Ah, okay.
So, and if the trace buffer is in a ring mode, so the trace buffer can be in different modes. So we have a mode where we're like, hey, please trace and just keep going and keep around the last 30 seconds. Mm-hmm. Kind of like a flight data recorder mode. You know?
Yeah. Yep.
So then it's just your position in the ring buffer, kind of. It's a little. It's actually, I think we OR together your position in the ring buffer plus a sequence number, so I forget.
Oh, that's great. Okay, so it's like record 30 seconds constantly, and then what, you can like touch it and say, give me the entire ring buffer, and then it just...
Well, yeah, that's fine. So there are 2 parts to the trace system. One is the embedding API, meaning I need like the thing we're talking about, which is these 3 method calls and then the giant macros. And that's what you're going to put into like, libuv or whatever it happens to be, right? Or hypothetically, right? Like this is what we're putting into V8. Yeah. In your top level, you've got the actual buffer, right?
Okay.
And that thing, the API is designed so that then you can implement all sorts of buffering implementations of your own. So if you look at our base trace event impl.cc, mm-hmm. That's our actual buffer implementation. So that implements these 4 core calls, and then has other methods like please start recording events in ring buffering mode. And so that then has a method saying please write your stuff now, if that makes sense.
Okay. Now you said there were 2 parts. One was the embedding API. What was the second part?
The buffer, like the control API. So this is start tracing, stop tracing, get data, right? And it's start tracing, stop tracing, get data, and get categories, right? Because the categories is sort of our log level kind of abstraction.
Yeah.
So it's like you'll have a probe, and the probe is the event loop probe. And so that we call a category. And so you can say, hey, trace system, please go broadcast out to all of your universe. Tell me what categories you know about. Yeah.
Okay.
So this is the moral equivalent of like when you're using like Linux tracing, you go ls bits of sysdebug kernel tracing, right? Looking at all the event probes that you've got. This is the userland equivalent of that.
Okay, so does this allow both counters and samplers?
Yeah. So this then gets to, if you think about what our tracers are, they're just, the fundamental operation is add event, right? Is this trace point on, meaning the category, and you check. That's your responsibility as a library to check if a category is on.
Mm-hmm.
Which is what this get category thing is for. And the other fundamental operation is add an event. And one of the first arguments of that is called the phase of the event, which is just the event type. And so counters are an event type, samples are stack samples are an event type. Async events, all of these things are just different event types with different data on them. Does that make sense? So the commonality is just an array of timestamped things with event types and then other crap. And so we shove everything down there, from the V8 sampling, which we're like literally in the middle of, to just this message loop was busy or idle at this point in time. We're not very used to explaining this. We just kind of hacked on this and make it work. Thanks for bearing with. Like, this is a bit of like institutional knowledge, essentially.
That's why we have a whole meeting just about it. Right. What's the status on getting this stuff exposed, like in JavaScript? Does any of that exist yet, or will we need to write like a small little?
Like the adding of events from JavaScript?
Yeah, and also like the control API as well, so getting stuff out of it would be really nice.
Oh, well, so we have the DevTools protocol has the control channel. Like if you look at Chrome's DevTools protocol, there are methods that we've come up with for the control. Right? So again, split it into like adding events, which is more about the data, and control, which is starting and stopping this. Yeah. We don't have hooks where you can, like, one of the things in this design is you're not allowed to get calls from these. We try to stop people from getting calls at the time that they happen. Does that make sense? So this system isn't designed so that you can have a probe in V8 and then get a callback right there, right when that happens in JavaScript that probe fired. Right? So this is very different than, say, dtrace, which is all about that sort of like immediate processing. We are of the belief in this architecture that you really want to just log a whole bunch of crap and then post-process it, because that's less performance intrusive. And that may not map well to server-side workloads, but that's working well for a client.
So I think also the question you're asking about the events. So currently V8 has this histogram timers, and these histogram timers are basically event-based or scope-based. And what we're trying to do now is take these histogram timers and have a proper format for them using the tracing backend or tracing format instead. Also with stacks, you'll find the CPU profiler code that currently dumps stacks, but this is what is currently controlled by the DevTools, and we're modifying that at the moment.
Are you talking about the sampler in particular there?
Yeah.
With the stacks? Okay. And I looked through that code a little bit. This is mostly for the UI thread, right? You can't really sample another thread there, can you?
You could. I mean, that gets back to like the tracing thing is super multi-threaded. So we have a depressing number of threads that are live in Chrome. Scrolling the page 1 pixel down goes to 14 thread pops.
Right, but what I looked through was that the sampler basically walks the stack and tries to, as far as I understood, it tries to even resolve like JavaScript and I think it keeps C++ in there if I'm correct. But it seemed like very specific to like the main thread where maybe your JavaScript executed and things happened. Is it that correct or is it totally off?
No, what we are doing is focused on that, but the format we're designing and the way that it'll map to tracing, you would be able to sample any thread you wanted and add stack sample events from any thread you wanted.
Okay.
I mean, we'd have to figure out how to do it, and I think one thing I would say is the timing of this is kind of perfectly bad to talk about sampling data in particular. If you give us about a month or two, maybe a month, and even a week, we're going to have a much more congealed plan on exactly how we're going to do sampling in V8 through trace event, and it won't involve big changes to trace event. It'll probably mostly involve. I mean, we'll have a reference implementation basically, and it should be pretty hackable once it's in.
Right, but it's basically totally separate from what you also talked about before, which was actually real tracing, like structured tracing with entry and exit, because the sampler actually uses Sinkrap, right?
Well, it's not in the sense that it is and it isn't. So here's the thing: is the sampler nominally gets turned on because the sampler is just another trace category, right? So if you want sampling, you turn on you use v8.sampling as a trace category. And when it's on, the sampling system starts the Sinkrap interrupts, and then in the interrupt, it'll do the stack tracing, and then there'll be some game playing because of Sinkrap, but essentially at the end of that, we will push an event into the trace stream of that sample. And then we will also push into the trace stream the code motion events. So what you'll end up with is a trace with sample events, phase P, with stack arrays on them, unresolved stack arrays, and then you'll also end up in the trace code motion event saying, this address range is this function, right? And then you'll also have your structural events in that trace too. And if you want to then combine that all into one unified view, you just do it after the fact by parsing this.
Okay.
It's a little hard to understand because it's really still up in three people's heads, but we're magically planned it.
So regarding the event scope, I see process and thread, which makes sense, but then also I see a global. What does that entail?
Really? Which file are you looking at?
In patch and tracing source tracing event.h. There's trace underscore event underscore scope underscore name underscore global G.
I'm madly trying to keep on. Tracing.h.
Meanwhile, I can.
Where in the file again?
It's
that stuff. Yeah. The event scope.
Yeah.
Okay. So sometimes you want to draw a big vertical line in your trace. So page load, right? Page is loaded. This is client side crap.
Mm-hmm.
So it may not be, or I'm trying to think of some plausible, just general thing, some instantaneous thing that just was really important and really just global to the world, like IOM'd or I don't know, the clock changed, right? Whatever it happens to be. So that is an instant event, and there's a big trace macro called trace event instant, which is a vertical line, and you can decide when you issue that one how big the line is. Is it something that applies to this thread? So, for example, this thread had an event, or is it per process, like this process finished loading the page, or is it global? So that's the idea with those. Those are only used for the instant event, basically.
I see. Thank you.
I'm still a little confused with regards to what's sample and trace? Because clearly the trace format, the trace event format is like entry exit, right? Like with
No.
the timestamp, right? Is that correct?
No, that's not. That's the key thing to sort of wrap your head around. A sample is like when we look at flame charts or when we look at like the dev tool CPP Prof, like that's the end. That's much post processing has happened on the data stream, but the input data stream is just an array of stack traces at given timestamps, right?
So you make it look like it. You make it look like it was taken structured, but actually it was the original was a sample, but you convert it into something that's structured.
Exactly. The structuring happens actually sometimes depending on the tool, but like for example the perf tool, the Linux perf tool, the sample. If you crack open the perf, if you run perf and do sampling, and you like crack open the file at just the right time, the perf file is actually just an array of stack traces. Raw stack traces and timestamps.
Right, right. I mean, so basically doing what I was doing with my trace viewer file, where I took a CPU profile, convert that into events.
And so the whole observation here is a trace is just an array of things with timestamps, and that's it, right? And screw the rest. Add more metadata so you know what particular thing this thing is. So the phase in a trace is the thing saying, okay, this is a sample, right? So we think of tracing as there's a container, there's sort of this broadcast bus, like designed for efficiency of like, here's a stream of performance information that all has timestamps. And we're going to blast that into a buffer, and then later we'll post-process it, right? And so we put sampling data down there, we put begin-end data down there, we put the load events, our network stack, netlog. So you'll see these nested async events. In here, that's a system we use to show the network stack going through each stage of a network request. Like, hey, we got the first bytes. Here's the rest of the bytes. Here's some more bytes. Here's the DNS resolve. So it's not just begin ends. It's arbitrary sort of time structured data.
Okay. So I'm posting in here what I'm referring to, the trace event format that I understand Chrome Tracing is using in Trace Viewer.
Yeah.
Which is all just events like entry exit, basically. Maybe some simple events.
This doc is the compendium to the header file, or the companion to the header file that everybody uses.
Right. And basically, as far as I understand, no matter how your data was generated, it could have been actually sample data, or it could have been actual trace data. In the end, you somehow convert this to make it look like it was trace data. Is that correct?
Yeah, I think so. I mean, yeah, we have all of our probes arranged to create this format through that API.
Right. No, because I mean, there's a difference. Like the perf tool, for instance, is sampling, right? Because it just like looks at every so often like what's going on. Then with dtrace, you can do sampled data, or you can also actually do real trace data. So I'm just trying to get my head around like.
Kind of funky. Perf is very cool. Perf, if you poke hard enough at perf, you can get it to give you a kernel trace. And instead of perf having these samples, perf will spit out timestamps at which the kernel switched what process was running. So perf and trace event are actually very similar. Like the fundamental unit underneath perf and tracing, perf is ftrace in the Linux kernel, and that's just timestamp plus some name, and so it's the same old thing, and then you shove crap in there. And then perf, the tool that we use, knows how to process that crap and turn it into various reports that we use.
So it's like perf probe.
Yeah, yeah, and dtrace is more, the big difference between like dtrace and these other ones is dtrace processes this stuff on the fly, right? On assumption that that's sane, and in some ways it is. Whereas our particular body of experience is with just buffering the hell out of it and then post-processing it later.
Okay, so I'm looking at the Chrome code for implementing the tracer. It's still a work in progress. It hasn't actually landed yet, it looks like.
No, it's still work in progress. The V8 side will land first, and then the Chrome side will land.
Okay, so the V8 side hasn't even landed yet?
No, I'm working on it this week and next week. Hopefully by the end of next week, it will be landed.
Okay. Okay, so once that version of this, we have to put this in core, or this be a module in NPM?
It can totally be a module. The fact that there is an include in the V8 means that anybody can include it in a native module. The trick, though, is if we want to place probes within core itself. So, like, we wouldn't even have to technically implement it, like implement how it's gathered or how it's used. All we would do is place probes at key locations within core code, and then people could tap into those using this API.
Right, but if we want to give them a JavaScript API to tap into it, we're gonna need to expose a JS API the same way that they're doing here for Chromium.
A user with a native module could do the same. I mean, it could easily be hashed out that way. We don't have to implement it right off the bat in core.
Okay, great.
Maybe with Trevor, if there was a C++ API where it was possible to tap into the trace events, that'd be useful, and would be able to be used directly, and people could kind of experiment with it. But it would have to be possible to tap it from multiple trace event consumers simultaneously.
Yeah, and see those types of implementation details I would want to happen outside of core, because as I well know, having written a Sinkwrap at least 3 times over an 8-month period, it's very difficult to do properly and to get people to agree on how it's done. The best way to do it would be to implement it and let people play with it, and then let there be consensus through usage.
So what I'm trying to say is I'm worried that multiple C++ add-ons wouldn't be able to play with it at the same time.
Yeah.
If it's useful, like consuming the event stream.
Yes, consuming.
We have not had good luck with allowing multiple consumers to be registered at a given time. We've tried. The key thing there is that different subscribers. One is subscribing needs to be asynchronous. So we've had a lot of performance problems come up where people if they get callbacks right away, we yanked that feature from the system. So we used to let people get callbacks right as the event happened, and that was a cluster. So we got rid of that. And the other thing was we used to allow multiple places to call to the control API and say, hey, please start tracing, these are the categories I want. And somebody else would say, start tracing, these are the categories I want. And what you do at that point is there is no good answer, and there are a lot of dead bodies there. So we've backed away from that as well, and we only allow one consumer at a given time. That's been good enough for us, but like that may be a problem for this community. I'm not sure.
Well, no, I completely agree with that stance, especially coming from the core implementation. If somebody wanted to attempt like a multi-use case module, basically be like, if you want to use multiple of these consumers, you need to first add this module, and then let people see, like, let other people experiment with how to do that properly. But I truly believe that should not be implemented in core. This is difficult enough. Trying to get that along with being able to juggle multiple usages of it at the same time is painful.
Also, with regards to the JavaScript API, I'm pasting something in here how the Node.js provider does it. I mean, that can definitely be done with a module, because all you're basically doing, you write C++ that you can basically kind of call from JavaScript that will add a probe, but it lives in C++ land, but you can basically add them from JavaScript. So that part definitely shouldn't go in core.
We've done we have like console.time and time end in Chrome map to trace event async calls, and in JavaScript we have the mark and measure API, which is kind of a questionable API, but the W3C liked it, so we have it. and that also issues trace events. So our JavaScript, our JS bindings in the back end of them on C++ end up issuing trace event calls. So that way, heavy JS code can add to the total trace, and then happiness results or something.
Yeah, I mean, I think to follow up on what Trevor was saying is that it's not that this won't ever go to have the discussion outside of core and see what works and iterate on it, and if something does go into core later, it should be proven out in the one thing. So because of the different rate with the system level probes, we definitely can't use this as the abstraction that we were talking about for the system probe stuff. But I'm wondering, Trevor, we've been talking about creating this unified endpoint for system level traces for dtrace and LTT and G. All as that, so turn.
Michael, you're breaking up.
Oh.
At least for me.
Yeah, me too.
Yeah, that's a problem with my internet. So if we have this unified endpoint, if we start sending stuff to trace event, those events will show up in Chrome tools and anybody else using this provider, right?
Yes.
One thing we've done, and this is maybe really in the details and maybe not the right way, but if you dig into trace event impl.cc and you look for ETW or a trace, I think is the other thing. This is in the Chrome side of things. We actually have the backend, so the buffering system calls into the OS when the OS tracing is on. So basically, when we know that the Linux equivalent, we don't use LTTNG on, but the equivalent that we do use, when we see it and it's on, then we issue our userland trace events into that tracing system in the backend. And we do the same on Windows. I don't know that it's great, because there's always a little bit of a mismatch between these APIs, but I thought
when you send them into the system tracer, are you still buffering them up?
No, we actually have tried both. I think we've tried both options. Once you have this sort of embedding layer where you've got the probes in one place, you can play games, right? You can lie and say, oh, tracing is enabled, right? But then you don't have the buffering on. Does that make sense? Let me try that again. Once you have everybody talking to a single probe producer API, how you interact with the system tracer can be done completely in your buffering, your implementation of trace event, which would be some core thing. So if you want that to redirect to a buffer, you can. If you want it to redirect LTTNG or dtrace, you can do it at that place. Maybe. I'm not sure.
So this unified system, would you like this to play with that? What seems like the smartest thing to do here?
Now, Michael, are you getting at how this feeds into Sinkrap, or?
Well, I'm wondering, do we just convert the existing dtrace probe points to trace event points, and then say, look, if you want to turn on dtrace, you're going to get everything. Do we create our own abstraction, put at these points, and then feed those into trace event when you turn it on?
For forward safety, I'd say the latter. I mean, the overhead of thinking through a tiny layer of converting a node trace point defined whatever in code to whatever this needs or whatever dtrace needs. I mean, I think that's getting a little bit too more detail into the details than what we need to cover right now. But off the top of my head, I'd say the latter would be the safest to do first.
Okay. I thought that we were going to get away with not creating a new API, but I guess we are.
Also, now, next thing on the list, unless somebody else has something else
I have a question about the trace event format and how close it is to the data retrievable from the trace buffer. Like, would it be reasonable to have a --v8 dump, like a trace option that would run Node and dump a file in trace event format, similar to the CPU profiling right now? Is that like,
Yeah.
or would that be a lot of post-processing?
Removing any dumping from V8 into D8 or the embedders in general. I don't think V8 will keep doing any dumps for the near.
So it would be the job of the embedder, so D8 or Node. But in Chromium, for example, you can say Chromium -- trace startup, and then you say trace categories, and you give the categories you want to turn on, and then that just dumps a file in this format once the startup's done. And so I'm sure you could map this. You could do a similar thing for Node if it made sense, right?
Trevor, I actually have a question for you. Like, do you see already where this could fit in with async wrap or whatever? Like, would we add a probe somewhere at some point?
This is completely supplemental.
Okay. I'm just wondering if there would be a probe there already, like by default, that we would.
No, there's no probes there. Like I built it so that async wrap can be tapped into.
Okay. But someone could tap into it and add a probe there every time.
Well, no, let me ask the V8 team, like, this is where I wanted to get into, so let's follow into the next subject and how it actually ties into async wrap. Do you guys, V8, do you guys have any background with async wrap? Do you want me to, like, do a quick
I don't
intro?
know about it.
About
Sinkrap.
No, nothing.
That was on my list. I'm sorry.
Oh, no worries. It's very confusing, and it's taken me almost a year to solidify. So I completely understand where you guys are coming from when you say like everything's up in your head.
Yeah.
So async wrap, I changed the internal APIs so that every subsystem in Node would go through a single class. The class is called async wrap because any class that is instantiated that can possibly make an asynchronous call in the future goes through this async wrap constructor. And so the user can be notified of when these classes are instantiated. Then they can attach like an object to it or generate a unique ID for it or whatever, right? And then in the future, just before the callback's called, they have a before callback they can call to like set up some state to collect information about what's about to happen, and then they have a teardown or an after callback that they can bring everything down after that's done. So they can take performance counters on a given callback or just like handle errors in a specific way if they want to. It's their choice. But it's very specific to Node in the way that it's implemented with being able to trace, like you can filter out subsystems and say like I only want asynchronous requests that come through TCP, right? Or I only want file system asynchronous requests. And I think that extends beyond the scope of this, but at the same time, there's a lot of overlap, so I believe that the tracing event would be implemented into async wrap. Does that make sense?
So you get callbacks, so you allow immediate callbacks to people, right? That's the big difference there, right?
Yeah, so say you set up an async wrap callback. You set up 3 right now. Create a before and after. So create means when this object is being instantiated, call this callback. And then you can every C++ class has an associated JavaScript object that the C++ class is attached to. You can then attach arbitrary information to the JavaScript object for longitudinal tracing. Then, so you could say like, in your create, you add a unique ID to it, and then you can add in the before and after callbacks called just before the asynchronous callback is about to be called, and then the after is called just after. And so you can actually check the state of the information you attached to the object and see like, okay, well, this object with this ID was instantiated here, its callback was called here, its callback finished here at this time.
Yeah, I think we typically do this with post-processing.
Yeah, and
that's how we probably, like, if I'm thinking about the use cases for which you're trying to solve, our orientation historically has been, oh, post-process that sucker.
yeah, and the usage of each is totally different. Like yours is tracing the statistics. Sinkrap was more so you can like actually affect the asynchronous request in transit for error handling or anything like that. So
yeah, like if you want to do long stack traces, you have to get it right when it happens, because if you don't, then the stack is gone, right?
Well, that bit is interesting because, like, well, it sounds like Sinkrap could issue trace events. Like, so
yes, it can. That's the key.
We have code in our message loops because, you know, for the, like, hey, this thing came from there, right? Arrows, basically. Like, if you think about this visually for a moment, you're like, this task here came from that task back then, right? And the way that looks in the trace file is that the poster issues a trace event flow start, and then when the run happens, you issue a trace event flow end, I think. And then that causality is in the buffer, and then you can go post-process that causality however you want to get like critical lengths or whatever it is.
So now, to me, this sounds great. Let's see if I can convey everything that's happening in my mind right now with this. Basically, by being able to implement trace event into Sinkrap, we'll be able to allow people to do things they're currently doing with Sinkrap in a better and faster way. Like, it still won't replace a lot of Sinkrap functionality, but at least for the tracing and probes to get like call stacks and stuff like that, that is horrendously slow. And a lot of people even do it in JavaScript, where they're doing error.capture stack trace, you know, on the fly in the middle of execution. It really slows down their code. Being able to do that.
What we do there is we say, hey, if you want something you want context on this post, then issue some structural traces, because that's way faster than stack tracing, right? So grabbing the stack versus saying, hey, no, please issue a few begin-end events to say what the hell you're doing, right? Or, you know, that's how we've solved it. But it's basically, we believe that the two big fundamental costs are in and out of JS or across these systems, because you leave optimized code paths, and stack tracing. Those are both things to be avoided when you can for performance reasons.
Oh yeah, definitely.
That's
like intended for you to be able to modify things, and trace event is very much intended that you cannot modify things. And in the few cases where people have, you actually rip that out. So.
Well, we used to let people do it, and nothing good came from this.
Could I ask you? Sorry.
Oh, one random aside is sometimes people want to store data with their event, so they'll say, I began this task, and they want to actually buffer like the URL of the task, or like some like all the headers on the task, right? And so we have a system in trace event for adding those headers, so that detailed metadata to the task, in sort of a absurdly efficient way. So if it comes down to like associating metadata with tasks, then ping us back and we can explain that part of the system, because there's some magic there as well. This is the end of my thought.
Okay, that's one thing I wanted to understand here is like, so let's just say we'd issue a trace event from Sinkrap and we get a stack trace. That stack trace would include C++ and JavaScript, is that correct?
Well, I'm not sure you want to issue a stack trace there, but if you wanted, you could grab a stack trace and it'll contain whatever. You could dump in the raw program counters, not stringify it. So do the V8 part of the stack trace that does the stack walk without doing the conversion to strings. Shove that into the trace event, because you'll have your core code will have V8 emitting the code motion events also into the trace. So that at the end you'll at least be getting the stack traces with minimal cost, right? The stringification is very heavy, is the point.
Right, I get that. And I guess when you're saying, JavaScript symbols resolving, right? Like I wouldn't have to run it with any of these prof flags that turn on JIT symbol emission or anything like that. Is that going to happen without those flags?
I don't know.
Basically, right now, in order to get JIT data, right, I can attach a callback whenever a code creation event happens, right, in order to collect information about JavaScript being generated and where it ended up in assembly.
You're going to have to turn that on for this to work.
Okay, so that was my question. Okay, thanks. That answered my question.
Yeah, like V8 will probably be modified to call these trace points. Like right now, you add an isolate callback, right, for that. There's like a bunch of isolate callbacks for.
Yes. Yeah.
Yeah. So instead of that, or in addition to that, because we won't remove those callbacks, the places in V8 that call those isolate members will also have inline calls that just say issue a trace event right now, right? Because the trace event macros, they're clever. They inline the call site so that if tracing's off, you don't even go into a phone call. So basically, V8 for every code motion will both call the trace event very lightly, and then will optionally go into that isolate callback. So if you turn on tracing, then you should be good. I mean, the devil's going to be in the details on this, right? But we think this will all hold together. Like, we just got to code it, kind of thing.
Right. I mean, and for me to understand this a little better, could you point me to some, like maybe there's some tests somewhere that already exercise what's currently there, so I could understand a little bit better how things work at the moment?
Well, sampling, stacks, all of that is our bleeding edge, so it's not in. When it's there, we can tell you.
Okay.
And the design doc is a bit of a wreck because we're in the middle of. Like that, we have a design doc is a miracle. So, but again, like 2 weeks and there'll be some stuff you can copy from, or we can chat again, I guess.
Well, it looks like, I mean,
trying to be evasive. I think right now we're not in a great place here, but we think we've got a thing that'll work.
Torsten, if you look at the V8 patch at source/log.cc, that has really basic usage of trace event begin and end.
Yeah, this is the logger, and the current logger is based on the histogram timers, and the histogram timers are basically scoped events. And they're currently plugged on all of the important functionalities in V8, including like parsing, compiling, and all of these stuff.
So what's checked in is not what we want. We're just in this.
This part is probably going to change. As a part that's going to stay is a V8 tracing.h, trace event.h, and event tracer.cc. The remaining, I'm still discussing with the V8 team how to get it the best way.
Interesting. Okay.
Is anything?
But it might not be. But the basics are the three files: event tracing, event tracer, trace event, and the V8 tracing.h. The remaining is just how can we use the current system and generate a lot of traces out of it before we actually migrate fully to that system.
When you said event tracing.h, you meant trace event.h or actual event tracing.h?
Trace event.h, event tracer.cc.
Thank you.
And do we know if this is going to affect the debugger API at all? Not the debugger API, the Chrome DevTools protocol.
The DevTools protocol exposes a tracing domain, and it's like tracing request handler.cc is where I know it's documented. I think there might be better docs, but that exposes basically start, stop, get data, and get categories, and possibly like get buffer status or something. And those are the control APIs, right? And those aren't going to change. So that control API surface is very stable in the sense that you say stop and what categories to do. It doesn't support nesting, and that's pretty stable for the long haul.
It's not understable in the doc.
Yeah, I think what we call stable goes through Pavel and Mr. Irish. From Chrome Eng point of view, we don't like changing that.
Yeah, this is Paul. So the tracing domain, you can check this out in the raw protocol, and it's just the protocol.json. It's not part of our 1.1 stable thing, but it's not changing. So we're kind of lazy in updating what's published as the stable protocol. But you can feel good about using the tracing domain.
So while I have everybody here, this isn't directly trace event related, or maybe it is, but why is the debugging port so slow on io.js and on Node 012?
If you had a trace, we could profile.
It appears after.
Bastard.
I could partially answer that. I can't give you a full answer, but the debugger got slowed down when V8 removed the debug agent that used to be in there in 010. And so we implemented one ourselves, but it isn't quite as robust, let's say, as the one that used to be there. We couldn't copy-paste the original one. So.
Michael actually in dot needed that one, Fyodor. So he probably is a better person to answer that question.
Okay, good. All right, that answers it enough for me to go and figure it out now.
Yeah. Also, in the issue, it appears they say that it's slower with like Node Inspector than if you just attach to it via the command line. For some reason.
That's strange. Okay.
Yeah, it's a weird issue, so there's something to look into. Anyway.
Okay. Okay. Cool. All right. All right. Anything else? We've got 5 more minutes.
There's, I don't know who added this, but it said, can we share async tracing facilities between io.js and Chrome, e.g. promises? See window.fetch. I'm not quite sure what that's referring to.
That was me that made that. I was just thinking of you were commenting before that you were trying to hook up like Sinkrap to things, and things like promises, because it like went into the microtask thing, they just kind of disappeared, and there's not really much you can do with that. So,
oh yeah, they break the world. Oh yeah. Thank you for bringing that up. So here's an interesting one. So promises are processed by the microtask queue, but it's impossible to tap into the actual execution flow of the microtask queue. And so like there's no way for me, especially like an async wrap, to be able to continue a call stack to anything that's been passed to a promise. Does that make sense?
Yeah, this is back to the async, the like trying to establish causality in the asynchrony. Right?
Exactly.
Yeah. I suspect that, I don't know when we'll get to caring about it, but like at least the trace events have a low enough probe overhead that we have a chance of maybe arguing for that in V8. But like phase 0 of this is we all have to get this all checked into V8. But we know that these probes are the best we got. So so I would say that right now it's a little early for us to know that this will all work. But like, this should work, you know, down the road. We should have a way to do this.
Mm-hmm.
Lord knows we've got enough bugs where it's like this promise is causing jank, and we need to attribute it back, right? Like, once we had this checked in, I believe we could create a Chrome/V8 joint bug / community bug and wrestle with this together, because I can convince myself that this is useful for client performance as well. Does that make sense?
Yeah.
Okay. As long as you're okay with this passive notification, right? If you need an active notification, then we're in danger zone, right? Because that's not how trace events works.
Yeah.
Right.
We'll cross that bridge when we come to it.
Yeah, so that's what I'd be cautious about, is that trace event, and I don't know that we would be able to help you with active notification, but passive is very much up our alley and plausible.
Okay. Thank you.
And my reasoning for mentioning win.fetch specifically was just because that's in Canary now as of like a month ago. So that's an example of promise.
I'm just gonna make people watch the whole thing.
Already available, so we can like try and track what happens there to make sure that that sort of style is debuggable everywhere?
Hmm. Cool. All right. I'm happy. Anybody else have any questions?
I'm good.
Sweet. So we'll keep an eye out for when this lands, and then relook over the patch and the implementation, and then we'll look forward to seeing what you guys get into Chromium. And I think that will serve as a great reference for implementation details that will go into io.js.
I think also I'll probably have an implementation in D8 that also will probably land faster than the Chromium one. But
Oh, great. Okay.
Awesome. Maybe we should open like a tracking bug for that on io.js so that everybody can get notified when it lands. Cool. All right, we're done. Bye, everybody. Great
See ya.
talk.
Thanks, everyone.
Thank you.
thank you.
Yep.
Thank you.